Right. Robert, you had an editorial in the New England Journal very recently about talk about genetic privacy and the question of presidential privacy. Please tell us a little bit about that, because that's an interesting avenue to pursue.
Sure. Well, with the presidential election a few months ago, we just were sitting around thinking that it wouldn't be very difficult at all to pick up some DNA from a presidential candidate. And it wouldn't be difficult at all to sequence it, or at least do a genome scan on it. And it wouldn't be difficult for people with the intensity of interest in the presidential candidate's health. It wouldn't be difficult at all to spin something. So for example, if there were a gene, I don't think there is, if there were a gene that suggested recurrence of melanoma, and that gene suggested that there was a higher probability of recurrence of melanoma, in Senator McCain, then someone could release that information in a way that would damage his campaign. So we simply wrote an editorial that sort of suggested that. And this is really back to my theme of incidental findings. I mean, what these would be incidental findings of possible medical significance in a presidential genome that could be spun by individuals in one direction or another. Now, herein lies the tremendous danger for confusion and for exploitation. Because not only, you've spoken to the idea of confusion, not only is it possible to be confused by susceptibility genotyping, by probabilities, by whether this is a real issue, whether it's an issue for your children, but it's possible for this to be exploited. And here we risk having industries like nutraceuticals jump onto the genetic revolution and try to sell worthless and unproven nutraceutical treatments in response to certain genetic variants. Cosmetics industry has already done this. Nutraceutical industry is trying to do this. The dating industry is trying to do this. And most of this is flat out pseudoscience with nothing supporting it. And so it's very important I know we really can't control, and maybe we shouldn't be trying to control the consumerization of genetics, but we do need to implant some sort of quality recognition, some sort of distinction, perhaps a hard line at some point between what is scientific, which is what Dietrich and others are trying to do, really use scientific principles, peer-reviewed literature to present information, and what is absolutely fraudulent.
Dietrich, let me have you pick up on that, because one of the things you've had to wrestle with over the last 12 months is this sort of patchwork state-by-state regulations. California sent you a cease and desist letter last summer, which you were able to negotiate with them and get around. But I guess New York State, which has the strictest laws, I believe, in the country, still won't let you spit in a tube and mail it off if you're a New York resident. At least you can't spit in New York. You might be able to go to Connecticut and spit. But what would you like to see in terms of the regulation of this industry?
I think there has to be some granularity with respect to quality of the technical aspects of the services, the interpretive services, et cetera. And so we actually welcomed and met all of those regulatory thresholds, some of which simply involve having a physician involved in the ordering process. So those are easy bottlenecks to work with. And I think more importantly, since we were on the HIT piece, what we've done is launch a national initiative called the iPrevent Initiative, and folks like Zach Kohani and Mark Boguski are involved. And what we're doing is working with the major clinical information system providers, the EMR companies and the PHR companies, to integrate genetics into the individuals who are captured within those. And then working with Microsoft, the Amalga product, there was a press release yesterday, suck all of that information into a database and then put a consumer-facing angle on it with HealthVault, and really be able to drive this prospective outcome process, but also integrate clinical data, exposure data, pharmacy data, grocery receipt data, so that we can do these massive data mining exercises to get at highly predictive models that will drive the content in the future. So that's another aspect.
Phil, tell us a bit more about, you touched on you know, the dearth of genetic counselors, and you know, most MDs, most family physicians, I mean, they don't want to look at SNP scores. They don't understand them in many cases. I went to for my annual checkup recently and dumped my 100-page Navigenics report on his lap. I mean, the look on his face was priceless, you know. What are you concerned about the level of genetics education in the medical community? What do we need to do?
Very much so, and I'm going to go a little bit wider in my answer to your question, if you don't mind. I've been thinking about how to best use 3 minutes with my colleagues in this audience, and I offer the following advice. You spoke about language, remove the word predictive from your lexicon. Nothing that we're talking about predicts anything in the way the consumer understands the word prediction. Substitute risk assessment or something like that. That would be the first point. 2, I think we've totally missed in our discussion so far discussions of a potential backlash against this information by the consumers. And I tell you where I'm worried it could happen, and this is something I've been deeply interested in for a long time. Talk about revolutions. We are on the cusp of a revolution in prenatal diagnosis. Moving from 25 years ago, where we just asked whether a fetus had Down syndrome, trisomy 21, to being able to assess hundreds or thousands of DNA variations associated with meaningful disease risk but uncertain phenotype, overwhelming the obstetrics profession. And this is not in 5 years, this is in 5 months. Companies like Sequenome have exciting new technologies. There's a company like Signature Genomics out in Spokane that is really pushing the envelope on prenatal diagnosis. We will move to an era of selective abortion rather than abortion because you don't want to be pregnant at all. It's going to be a very different set of ethical circumstances. The other thing I'd like to point out is I don't think we've at all discussed yet what may be the single biggest application of the exciting technology that Cliff has talked about. Let's just sequence every newborn in the United States. At the numbers he's talking about, $1,000 a person, 4 million people, $4 billion a day in Iraq. And we'll have the entire sequence. Then, the ultimate biobank, we follow everybody over time. I think the informatics and the DNA are there, and yet our current newborn screening in the United States is anchored in, by and large, 1960s technology with the recent change brought about by tandem mass spectrometry for certain inborn errors of metabolism. The best state in the United States does maybe 40 to 50 newborn diseases. We could add 2 zeros to that very easily and learn a lot more about these diseases in a much more efficient way than thinking about late onset disorders like asthma, cancer, heart disease. We could really learn a lot more about disease progression. And as for the education issue, I mean, I think we're going to have a whole new model to educate physicians, and I don't have the solution at all. But the kinds of services that were articulated earlier clearly cannot be used in any massive way with the general public. And waiting in the wings, of course, are the lawyers for the lawsuits for misunderstanding of the information. I could give you a lecture right now from the podium, being both a geneticist and a lawyer, about the influence of malpractice litigation on standard of care and genetic information in the last 30 years in the United States. It has been hugely influential.